E-Chemistry Plus, Fatima Convent High School, Chapter 4, Carbon and its Compound. Myself, Dipali, Class 10. In the second session, we are going to understand bonding in carbon and covalent bonding. Now first, let us understand what is the meaning of covalent bonding. Now in chemistry, the two major types of bonding which we observe in any substance is the covalent bond and the ionic bond. We have already studied about ionic bond in the previous chapter. So ionic bond is nothing but the bond formed by the exchange of electrons, whereas covalent bond is the bond formed by sharing of electrons. If you take a simplest example of ionic bonding, it is Na gives Na plus electrons and Cl plus electrons gives Cl minus, and this now an ion and cation will try to combine and form NaCl, whereas in covalent bonding there is sharing of electrons instead of give and take of electrons, and the bond is represented by a dash between the element. So this is covalent bond. So you can define covalent bond as the bond formed by sharing of electrons. Now let us brief ourselves a little bit with the ionic compounds, and then we see what is the characteristics of covalent bond and substances forming covalent bonds, and we understand bonding in carbon. In previous chapter we have studied the properties of ionic compound. We saw that ionic compound have high melting and boiling point and conduct electricity in solution or in molten state. We also saw that the nature of bonding in ionic compound explains this property. Let us now study the property of carbon compounds. Most carbon compounds are poor conductors of electricity, as we have seen in chapter 2. From the data given in table 4.1 on the boiling point and melting point of carbon compounds. So, the ionic compounds have higher melting and boiling point and are good conductors of heat and electricity because of the free electrons present in them, whereas covalent compounds do not have any electron transfer or free electrons, and so they are poor conductors of electricity and their melting and boiling point is very low. As you can see in the table, acetic acid, chloroform, ethanol and methane, their molecular formulas, their melting point and their boiling point. So this is what we understand about covalent bonds and properties of substances forming covalent bonds. But let us find out the reason why this happens. So, most carbon compounds are poor conductors of electricity, as we have seen in chapter 2. From the data given in table 4.1, on the boiling and melting point of carbon compounds, we find that these compounds have low melting and boiling point as compared to ionic compounds. We can conclude that forces of attraction between the molecules are not very strong. Since these compounds are largely non-conductors of electricity, we can conclude that bonding in these compounds does not give rise to any ions. In class 9, we have learned about combining capacity of various elements and how it depends on the number of valence electrons. So let us now look at the electronic configuration of carbon. The atomic number of carbon is 6. What would be the distribution of electrons in various shells of carbon? How many valence electrons will carbon have? So let us understand this concept. We know that the reactivity of element is explained by its tendency to attain a completely filled outer shell, that is, attain the noble gas configuration. The elements forming ionic compounds achieve this by either gaining or losing electrons from the outermost shell. In the case of carbon, it has 4 carbons in electrons in its outer shell and need to gain or lose 4 electrons to attain noble gas configuration. If it were to gain or lose electrons, so it would gain 4 electrons, form C4 minus and ions, then it would be difficult for the nucleus with 6 protons to hold onto 10 electrons, that is 4 extra electrons. And if it were to lose electrons forming C plus cation, it would be requiring a large amount of energy to remove 4 electrons, leaving behind a carbon cation with 6 protons in its nucleus holding on to just 2 electrons. So, carbon overcomes this problem by sharing electrons with other atoms of carbon or with atoms of other elements. Not just carbon, but many other elements form molecules by sharing in this manner. The shared electrons belong to the outermost shell of both the atoms and lead to both atoms attaining the noble gas configuration. Before going on to the compound of carbon, let us look at some examples of molecules formed by sharing of valence electrons. So as you understood that carbon valency is 6 and its electronic configuration is 1s2, 2s2, 2p2. If you try to see, then its valence shell is having 4 electrons, so valency is 4. Now this valency could be plus 4 or it could be minus 4. Plus 4 means it is having total 6 protons, and now because it is giving away its 4 electrons and becoming plus, it will have only 2 electrons left. Now because of this, the positive charge is very high and the atom will become unstable. Same thing when you talk about minus 4, means it is taking 4 electrons to complete its octet. So it is having 6 protons. Now 6 electrons plus 4 electrons, so total 10 electrons. This also will make it very unstable due to the difference in this electric positive and negative charge. So to avoid this instability, because in chemistry most of the elements try to become stable, it will do the sharing of electrons and it can form 4 covalent bonds, and so its valency is tetravalent. It is called as tetravalent because it can share 4 electrons. Now let us understand the structure of few elements. That is, first one is H2 molecule. The hydrogen molecule, which forms a covalent compound with another hydrogen atom. Then we will be understanding about the chlorine atom, oxygen atom, water molecule, and the NH3 and N2 molecule and methane. So now in H2 molecule, if you try to observe, then the electronic configuration of hydrogen, there are 2 hydrogen atoms. So one hydrogen atom, it is 1s1. Therefore, if I draw the Lewis dot structure, it can be shown like this. Now, if it gives away this, then it will be plutonium positive ion, which is unstable, and if it takes, then it will attain helium configuration. But for that it needs another hydrogen, so it takes another hydrogen which is also having 1 electron. Now this combines, it gives us H, and so now both of them have completed their valence shell, and you can see 2 electrons in each, and this is the bonding pair. Now if there is one bonding pair, means it is forming one bond or one single bond. So it will be represented by H-H, which is H2, and it is a single bond. Covalent bonds can be classified as sigma and pi bonds, and it can be classified as single bond, double bond, and triple bond as well. So here there is a single bond. Same way, if we take example of Cl2, then the atomic number of Cl is 17. So 1s2, 2s2, 2p, 6, 3s2, 3p, 5. So its valency is 7. Now, if you put the Lewis dot structure, you will get 1, 2, 3, 4, 5, 6 and 7. It has one electron unpaired. So, it will take another Cl atom and have 1, 2, 3, 4, 5, 6, 7. So, this also has one unpaired electron. This electron will form a pair and make one single bond between the two atoms. So this is the structure of chlorine, where it has completed its octet by sharing the electrons, and it is having one single bond, Cl-Cl. So this is how you can understand the covalent bonding in hydrogen and chlorine atom. So here, the simplest molecule formed in this manner is that of hydrogen. As you have learnt earlier, the atomic number of hydrogen is 1. Since hydrogen has one electron in its valence shell, it requires one more electron to complete the atomic number of hydrogen is 1, and hence hydrogen has one electron in its K shell and it requires one more electron to fill the K shell. So, two hydrogen atoms share their electrons to form molecules of hydrogen H2. This allows each hydrogen atom to attain the electronic configuration at the nearest noble gas, helium. So, you can observe the Lewis dot structure and representation of hydrogen. Here you have, so we can depict that using dot or cross to represent valence electron. The shared pair of electron is said to constitute the single bond between the two hydrogen atoms. Single covalent bond is also represented by a line between the two atoms as shown in the figure. The atomic number of chlorine is 17. As we already understood this, what would be the electronic configuration and its valency? Chlorine forms a diatomic molecule, Cl2. Can you draw the electron dot structure of this molecule? Note that only the valence shell electron need to be depicted. In the case of oxygen, we see that the formation of a double bond between two oxygen atoms. It is because an atom of oxygen has 6 electrons in its L shell. The atomic number of oxygen is 8 and it requires 2 other electrons to complete its octet. So each atom of oxygen shares 2 electrons with other atom of oxygen to give us the structure shown in the figure. The 2 electrons contribute to each carbon also. Atom gives rise to 2 shared pair of electrons. This is said to constitute a double bond between the two atoms. Now let us understand the bonding in oxygen atom. So we know O2. The atomic number of oxygen is 8 and its electronic configuration is 1s2, 2s2, 2p4, means it has 6 electrons in its valence shell. So valency is 6. If I represent the Lewis dot structure, I get O, 1, 2, 3, 4, 5, 6. Another oxygen atom I take 1, 2, 3, 4, 5, 6. Now this orientation for bonding is not appropriate, and so the atom will rearrange itself in such a way that the bonding becomes easy. So here you can observe that it is forming a bond between two pairs, and so you can see it completed its octet of 8 but in the same orientation. And so now you can represent O double bond O because here 2 pairs of electrons are shared. And so this is an example of double bond. Now if you see the water molecule H2o, then H1, 1s1, O8, 1s1, 1s2, 2s2, 2p4. So now you observe oxygen, then 1, 2, 3, 4, 5 and 6. Now if you see hydrogen, it has one electron in the outermost shell. So the bonding will be something like this way. This is a water molecule and you can see there are two single bonds, one on each hydrogen and oxygen atom. This is your H2O molecule. So do you observe the structure of oxygen, that is a double bond, and a water molecule? Here, in the case of oxygen, and we can now depict a molecule of water showing the nature of bonding between one oxygen atom and two hydrogen atoms. Does the molecule have single bond or double bond? It has a single bond. What would happen in case of diatomic molecules like nitrogen? Nitrogen has atomic number 7. What would be its electronic configuration, its combining capacity? In order to attain an octet, each nitrogen atom in a molecule of nitrogen contributes 3 electrons, giving rise to 3 pairs of electrons. This is said to constitute a triple bond between the two atoms. The electron dot structure of N2 in triple bond has been depicted in the figure here. Now let us see the N2 molecule. Now N2, its electronic configuration is 1s2, 2s2, 2p3. So it has got 5 electrons. So 1, 2, 3, 4 and 5. Same thing, 1, 2, 3, 4 and 5. Now here, if this bonding takes place, 3 electrons are free here and 2 are here. So it has to try to orient itself in such a way. So 1, 2, 3, 4, 5. Then 1, 2, 3, 4 and 5. This is how it will be showing the bonding, and so nitrogen will form triple bonds. That is, N2 has a triple bond. Now let us check ammonia. So that is NH3. N is 7, 1s1, 1s2, 2s2, 2p3 and H is 1, 1s1. So if we try to arrange, I have 1, 2, 3, 4 and 5. Now hydrogen, I will have 1H here, 1H here and 1H here. So if I try to observe, I will get a structure like this. And a lone pair. This pair is called lone pair. And so it has completed its octet in this manner. And you get N H N H H, that is NH3. This is the ammonium molecule. So you can easily observe how in ammonium molecule, a molecule of ammonia has formula NH3. You can draw the electron structure for this molecule showing all the 4 atoms achieve noble gas configuration. We already saw that. While the single bond between each nitrogen and oxygen atom. So let us now take a look at methane, which is a compound of carbon. Methane is widely used as fuel in major components of biogas and compressed natural gases, CNG. It is also one of the simplest compounds formed by carbon. Methane has formula CH4. Hydrogen, as you know, has valency 1. Carbon is tetravalent because of it has 4 valence electrons. We already understood the valency structure of carbon. In order to achieve noble gas configuration, carbon shares these electrons with 4 atoms of hydrogen as shown in the figure. Such bonds which are formed by the sharing of electrons between two atoms are known as covalent bonds. Covalently bonded molecules are seen to have strong bonds within the molecules, but intermolecular forces are weak. This gives rise to low melting and boiling point. Do you understand now? Since the electrons are shared between the atoms and no charged particles are formed, such covalent bonds are generally poor conductors of electricity. So this is what we understand. Now let us understand the structure of methane in detail. So CH4, where carbon is 6, 1s2, 2s2, 2p2. Hydrogen is 1, 1s1. Now if I try to observe, then structure of carbon will be something like this and hydrogen will be something like this. If I show the bonding, I get so when you form it, all hydrogen are completing its valency and even oxygen. The carbon, and so you get HCHHH. This is a methane molecule. Is that clear? Yes. So now we understand what is a covalent bond, and the properties of covalent substances are they have low melting and boiling point, and they are poor conductors of heat and electricity. Is that clear and easy? Okay. So we shall understand in the next session about allotropes of carbon. Thank you.